Hello everyone. In this tutorial, I'm going to query Wikidata from a local knowledge graph environment. To do so, I installed Apache Jena and Fuseki on my Linux machine. It works the same way on Microsoft Windows. So why did I pick Apache Jena? Well, I have quite a few years experience with knowledge graphs, and to my opinion, Apache Jena can easily compete with other RDF environments that are practiced in the industry, such as Virtuoso, Stardog, France Allegograph, or the Oracle Triple Store. Plus, Apache is open source, that means it's free. So let's go first to the Apache Jena website. This is where you can download your data. So we will need the SPARQL endpoint, which is here, Apache Jena Fuseki, and we will need also the Java environment. This is the SPARQL endpoint alone. If you don't do any Java, you can just keep that and ignore the second one. We will do both. When you unzip those files, you will get quite a few examples to be used. And I show you my Eclipse environment where I just deployed what they call Jena examples. They give you a POM XML file here, and with Maven, you can just deploy it. And then you have an idea of how to program Java using the Jena API. This comes also with quite a lot of documentation. So when you go here, you have some tutorials. We have some documentation about the different parts of Jena. And Jena itself is the combination of a Java API to access the database, to retrieve data, to do some external calls. This part here called arc is also a command line editor. We will use that one to demonstrate the use of SPARQL queries. And TDB is the database, so you can store your data on a triple store. And the last part is Fuseki, which is a SPARQL endpoint. Fuseki can be installed in two different ways. I'm going to install it standalone, but you can also, in the zip file that you just downloaded, take this WAR file, WAR, and deploy it on an application server such as Tomcat. Okay, so in my previous video, I showed how to run SPARQL queries on Wikidata. And so let's first have a look at Wikidata main page and then do some SPARQL queries on the Wikidata query service here. The target was to retrieve the list of French Impressionist painters. So one painter is, for instance, Renoir. And the first one is correct. And this is what you get. So you have some labels, some description, depending on the language, and you have pictures, you have quite a lot of information. We are going to pick some of those information, like date of birth, date of death, what else? Here, occupation. We're going to take this, painter, and the movement is impressionist. So here you see when you hover over the values, you get an ID. Like movement is also an ID. And we will use that ID to generate our SPARQL query. So I already opened my Wikidata query service, and I already created my SPARQL query. If you don't know how to use SPARQL, you have here quite a lot of examples on how to query SPARQL on different topics. We already have a query built here. So my variable name painter is an instance of human and has a family name. So variable is name, has as an occupation painter, is citizen of France and is part of the movement impressionist or post-impressionist. So I used the filter and I said the movement is in one or two of these values. Then I'm also retrieving the gender. So we have this here, gender, the date of birth, the date of death, and the date of the death. We put it optional because this painter might still be alive. And then we have this special service syntax from Wikidata that allows you to retrieve in a quite easy way the label and the description of the painter, for instance. So let's run this query on the Wikidata SPARQL endpoint. So when I open this one, let's say Pissarro, I come to the Pissarro Wikidata page and I get all the information for Pissarro. And this is now exactly what we want to do on our Fuseki SPARQL endpoint. So my Fuseki SPARQL endpoint is here. It runs on port 3030. And I already created one database called painters. It could be empty for our use case here because I'm doing a complete service call to Wikidata. So the part here is the same as what we have seen on the Wikidata query service. And we have to add this here with the address of the SPARQL endpoint. And we have to add all the prefixes used in my SPARQL query. So for instance, we have VDT and VD here. This is coming from Wikidata, and you have a list of prefixes, so you just have to cut and paste whatever you need, like this one, VD for entity, VDT for property, from that page. Okay, so here I'm on Fuseki, and now I can run it. And we get exactly the same result as in Wikidata. And I can open this link, and I come to the Wikidata page for this specific painter. Okay, so that's one way to query data using Jena. Second way is to use the command line tool. So the command line tool is here. I already opened the page where I have put the queries. So you have two command lines. One is SPARQL and the other one is RSPARQL for remote calls. SPARQL alone is used when you query data from a local file. So RSPARQL gives you, here are the parameters. So here we have to add this minus service and put the Wikidata service call, and we have to put a file next to my query to be able to retrieve the data. So let's take one example. Here, the first example is here. I'm saying that our SPARQL service Wikidata, and the query is Wikidata painter.rq. Okay, so it's calling Wikidata and it's retrieving the data here on my page. If I change a little bit my query by adding minus minus results equal JSON, I get the same information, but in a JSON format. So that's one way. By the way, here, this Wikidata painter.rq is my query. So if I'm opening this .rq file, it looks like that. So we have, again, the prefix declaration. We have the select statement. We don't have to put the service call because this is part of the command line command rsparkle minus minus service, and then you execute the query. The third option with Jena to query data from Wikidata is using Java. So I already created one Java class here, and it's using exactly the same query as we have seen before. But here I'm adding service, and I'm passing the service call to wikidata.org/sparkle. So that's all. I'm then executing this print to see the exact query as it is, and then we execute the query. So let's do that. Run as Java application. And here we go. We have the complete list of French Impressionist painters. Okay. Now, next step, I'm going to put some data in my triple store, my local database, and I want to merge the information stored there with the information found in Wikidata. So it's in a single SPARQL query, doing a merge, calling Wikidata and calling my local data. So I won't start from scratch, and I'm going to take data from another SPARQL endpoint, which is dbpedia. So let me go to dbpedia. Here we are. So it's another SPARQL endpoint with quite a lot of data on similar things than Wikidata, and it has a SPARQL endpoint. So I already prepared the SPARQL query. Here I'm asking for a painter, a name, the Wikipedia link, and the movement. Why the movement? Because I said I want to have primary topic of Wikipedia. Movement is Fauvism or movement is Impressionism. But if it's Impressionists, I only want Monet, Renoir, Morisot, Pissarro, and Cézanne, not more. So I can now run this as HTML, and I get my complete list of Fauvistes. That's the only one that are found at dbpedia, and my 5 Impressionist painters that I mentioned in my query. So now, if I want to upload this into my triple store, I need to have another format as HTML. So I'm going to take n triples. I execute the query and I get this. This is not what I expect. I don't want to have something like result 2053 type and so forth. I want to have a nice subject, predicate, object setting. So how to do that? Well, instead of doing a select, we are going to do a construct on this SPARQL endpoint. So my construct is here. So the construct part in the where clause is the same as before, but here I'm saying instead of select, construct. And construct painter is a person, has a label, RDFS label name, is part of movement and has a Wikipedia address. So I want n triples, execute. That's it. This time I have my subject, predicate, object, subject, predicate, object structure as expected to be uploaded in my Jena environment. When you see things like that, don't worry. These are Unicodes. Um, for a, for a triple store, URLs should not contain Unicode like accents or some special characters. It should be replaced by a Unicode. So you won't see any difference when you do the query later on. You will see the exact structure of the name. Okay, so that's my first data set. I just have to say save page as, and that's it. I will have my file to be uploaded. The second file to be uploaded, I created it myself. It's link Wikipedia painters. So it's another file, this time not as ntriple, but as TTL in the format. Um, Fuseki will understand both languages, so it's not an issue here. And I'm saying that Paul Cézanne, here you see the accent is transformed into Unicode, is a person, so we already have this information. It's not going to double the triple. It will detect that this triple already exists, so it will not just create it a second time. We gave a FOF name to FOF means friend of a friend. It's another ontology definition that you can find at W3C. And I said that the name is Paul Cézanne, and I'm putting the Wikidata link, this Q IDs that we find in Wikidata. So I'm only putting Wikidata link for these few painters. The other will not have it. The prefix P, I just created one by myself. This is my web address, /ontology/src. So it's just an example. So let's go to the Fuseki. But first, I will clean up completely my Fuseki is here. I'm going to completely delete my database to be sure that there is nothing left. So it's not a query, it's an update. And I will execute that, and it tells me that the update is succeeded. Actually, it's not an update, it's a delete, but it doesn't matter. If I go now to the database, I see that we have count 0. Okay, so now I'm going to add data. I'm selecting the two files that I just mentioned. So the two files are here. And I said a Wikipedia construct. We will open that one. I'm going to select the second file, the link here, and I'm saying upload all. So now both files are uploaded. I can check. Now I have 204 triples in my triple store. Okay, so now I can do some queries on my triples. First query, here we are. First query is simply calling, doing a query on my local data. And because I asked for the Wikidata information, and only a few painters have the Wikidata information, I won't get the whole 204 triples. I will just get a few of them. So if I remove that, and I say I don't want the VID, I get much more. Okay. So my query against the local triple store works. Now let's double check if my query against Wikidata works. So I'm calling query Wikidata SPARQL, and I'm checking for my painters, impressionist painters. Works. Okay. So now I'm going to make a mix of local data with Wikidata data. So again, my prefix, here is my workloads. I'm calling local data, DPpedia movement, this P Wikipedia, this P Wikidata, that's all local. And then I'm doing a second block here with service call to Wikidata. And I would like to have the Painter, Wikidata Painter linked to the Wikidata Painter from my local data. So let's execute that. Takes a while. And it's not what I expected. Claude Monet, DPpedia name is linked now to Wikidata Painter label, to this label, and so forth. So it's not correct. The match is not done, and I cannot use that syntax. The reason is this service call here. This special syntax of Wikidata is giving us troubles. So we have to replace, to ignore this service call and replace all the labels by RDFS label and description by all the different syntaxes I showed in my previous video. So let's do that second try here. And execute that. And this time, as you can see, Monet is linked to Monet, Pissarro is linked to Pissarro. So I have now data coming from my local database, that's this part here, and data coming from Wikidata, this part here, and it matches. How did I do that? So as you can see, I removed the service call and I use this RDFS label syntax filter on French or English, whatever you want. And this is the correct way to do the combination of both worlds. Now the question is, how is it working? Is my Fuseki engine going to call Wiki data and retrieve all the data set, the complete data set, and then compare it to my local data set? Or is it going to call only the data that my local data set wants to? Just to demonstrate that it's really only calling what is needed, I mean, only the few one, I'm going to show you this query on Wikidata with a count. So if I'm only asking for the French Impressionist painters, which this is what I did in my query before, I get only 59 painters. If I'm removing French and Impressionist from my query, I will get 191,000 painters. And if you want to retrieve this 191,000 painters from Wikidata, Wikidata will tell you that it's not possible. So let's try to do the last query here on my Fuseki machine. And this time I'm just asking for the occupation painter. I could even remove that, but let's just keep my 191,000. And I'm going to make the join with VD Painter on the Wikidata website. And now I execute my query. And it comes as fast as before. So 2 seconds to do the whole query. And Monet matches Monet and everything matches everything, which means that we don't have to worry about retrieving too many data from Wikidata. This trick here by joining using a service call is working on small amounts of requests to Wikidata. So that's it for my demonstration. One last comment, I would say this trick works if you have more complex queries to do. It might be better to use Java and to do loops on one triple store and then store that in memory and do a second loop on the second triple store that in memory, and then do your mix. It will be sometimes more efficient. But for a case like that, it's perfect, it works, and you can retrieve your data. Also, be careful, not every triple store behaves like the others. I had some surprise with some triple store that wouldn't do that join as shown here. So be careful, test it first. My demos are available, the scripts are available on my website if you need them. So thank you. Bye bye.